So these are other examples of brief examples of testing a certain value using the test command. I'm not going to spend a lot of time. This is just an example of the code, and the rest of this presentation is showing you examples of shift instructions. So shift instructions, it's easier to see these diagrams that when you have a certain data type, it's possible to shift bits to the left and to the right. So for instance, this is called shift left and shift right. So these are mnemonics of the two commands. And with them, for instance, shift left is moving, of course, in a direction from right to left. And all of the bits are shifted to the left. And the lowest bit is filled with 0. And the number of shifts is specified by the ECX register. Let's just put it this way. And these shifts could allow us to multiply and divide. So this would be multiplying by powers of 2, and this is dividing by powers of 2. I'm not going to use examples right now because we will actually try to use these in shifts in places of arithmetic specific to multiplication and division. So in the future we will revisit these instructions. But there are some examples here that talk specifically about certain things, like how do you specify the count. But we will discuss this in the future. Rotate instructions are similar to shifts, but they, instead of filling things with zeros, they actually rotate, keep rotating, and even push out value into the carry flag inside the flags register. So this is just a general idea what kind of instructions exist for you, and of course they be appropriate to use in specific situations. So other types of these instructions, not those will be covered later on. Equivalent directive is just something that I find to be extremely important. When you look at the code like I've written right here, all of these magic constants, 5, 10, and even values like this, when the program is written, render it quite difficult to interpret, because it's very difficult to remember from one line to another what was 5 and what is now 10, what is the meaning of them. We call these things magical constants. So it's possible to take all of this, and even a bit pattern like this, right? If I want to, instead of this, if I want to use a normal identifier for it, it's possible to create a constant. You can place them in anywhere in the source file, but I normally place them under const in the constant data segments, because when I start looking for my constants, I normally search for this to find constants. So here we can just take this. Of course, this is a binary number. I will make it even less readable by converting it to a really long binary number. And binary numbers can be used in assembly. They either using suffix b, but b is a little difficult. It kind of like blends with the rest of the bit pattern. So we also can use suffix y. So this is more acceptable. And now I can say that this is a bit pattern, whatever, it's just meaningless, just some kind of bit pattern, okay? And I can say which is equivalent to this. And so now this bit pattern becomes a constant that assembler will recognize and will know that this is that, okay? And in our code, for instance, I could say move into some register, whatever, we seem to be using EAX a lot today, so we can just move this bit pattern, right? So arguably naming something is a better choice when, you know, when these things have meaning and we want to give them some names. So likewise, this could be counter of iterations, and this could be a threshold value for some kind of error counter, whatever. It's just something that could be given a name. So use this equivalent directive, and it will create a constant for you. Notice that this once equivalent is used, no reassignment is allowed. So this becomes a true assembly time constant. So let's just build this to make sure that everything is working properly, so it's continues to be compiled fine. So this is an example of using equivalent, and of course when you're dealing with strange things that look like this, it's much better to give them some kind of real names.